Welcome to Intralogistics Insiders, brought to you by Sinaos. Explore the latest trends, challenges, and innovations in intralogistics with industry experts. Welcome to Intralogistics Insiders podcast. We have today Javier Miguelez, president of ARME and consultant at Moving Robotics. Welcome to the show.
Hello, Javier. Good afternoon.
So, tell us a little bit, what are you doing? What is ARME? And what are you doing with Moving Robots?
Oh, so many questions put together. So ARME is the Spanish Mobile Robotics Association, as you have mentioned before. And what else I can tell? You're one of the members, actually, of the association. Let's say that the most important thing that we can say about ARME is that the goal is to make Spain become the worldwide benchmark in mobile robotics. That's our target.
What about Moving Robots?
Moving Robots is a company dedicated to consultancy in the mobile robotics world. This means that we can help both industrial companies and technological companies, both sides.
Many people may know you from LinkedIn. You have been very active in the last years, but your focus has been always on intralogistics.
Correct, right? That is correct. So LinkedIn is just a tool, a communication tool. Very good communication tool, by the way.
So I want to start with first question.
Yeah, okay? Sure.
What is the reason for this need of automatization of intralogistics?
Costs, directly. This is the first reason.
Where does this cost saving come from?
Mainly two sides. The first side would be the operational cost itself. So the cost of the human resources working in intralogistics, and the second cost would be the cost of the different technologies that today have been used in or are being used in intralogistics operations.
So there is definitely a skilled worker shortage.
That would be a second one that's not directly linked to the costs or to the operational costs.
Okay.
So let's say that we have the operational costs that you can divide them into two: the cost of the operator, of the intralogistics operator, and the cost of the technology that you are using right now. And then you have other factors that may affect or may impact in the landscape of intralogistics and the automation of the intralogistics processes.
How are automation technologies or implementing automation technologies impacting operational efficiency?
In many cases, they are not impacting in the efficiency. So when we automate, it doesn't mean that we are going to be able to do a task in less time. It's not that. So the automation is needed to reduce the impact of human labor in the intralogistics operations. That's the main goal of the automation of intralogistics. So it's not to increase the efficiency of the different applications, but to reduce the cost by taking out of the equation the human labor.
Okay. How do you measure the success or cost reduction improvements in operations?
In euros. In the end, this is like two columns, and in the first column you have the manual cost, and in the second column you have the automation cost, and you have one versus the other for years. So the manual cost for 1 year versus the manual cost or the automatic cost for 1 year, and that's what you.
Is this the only reason?
No, I'm not saying it's the only reason, but it is the main one.
Okay. What are the other reasons?
You have mentioned one, labor shortage, for sure. That's becoming more and more important, but today labor cost is still the most important one.
Okay. Even though many companies are integrating automation and automating processes with mobile robots and other processes, still most of the processes in companies are based on manual labor.
Yeah.
So how do you see the integration of automation and manual labor in the present, and where do you see it in the future?
The interaction between human labor and automation is quite common where there is automation, of course. In those places where you can find automation in intralogistics, there are people working as well. Most of the AGVs are prepared to work side by side with humans. They are prepared for that. That doesn't mean that they have to work with humans side by side.
Today, most of these processes, the manual labor, are offline. I mean, it's difficult to keep track of them live like you would do with mobile robots.
True.
Right?
That's correct.
So how can you increase the efficiency of those if they're offline?
If you cannot measure, you cannot improve. So first you have to measure. You can measure your processes online or not. But the first step is to measure. Then you can do it online or not.
What do you think are the biggest challenges that companies are facing when integrating these new technologies?
Fear. I would say that fear is the most important stopper. Fear to fail and a fear to something new. Particularly fear to something new, I would say. And then, so if they have no experience with automation, and then the lack of knowledge. They know nothing. Most of the companies know nothing. They have no knowledge about automation.
What is more important, hardware or software?
Neither one or the other. Application and application design. We have discussed several times already that there is a percentage of AGV and AMR projects which in the end don't work. Around between 20 and 30%, more or less, or between 10 and 30%, depending a little bit on the country and on the industry. But there is a high percentage of projects which are not finally working. And for me, the reason behind that is mostly the lack of a good design of the application. So the most important thing is to design it correctly, and then comes software, and then comes hardware. And the installation of that software and that hardware, for sure.
How do you justify the cost of investing in automation to companies?
Saving human labor. That's the way to justify
This can be calculated in advance?
Yeah, it's usually calculated in advance. It's almost always calculated in advance. I mean, you're not going to invest into a project if it's not going to be profitable.
Do you think it's really completely replacing human labor, or will they need other type of human labor?
They need another kind of human labor, sure. Yeah. By the way, much more skilled.
Do we have that skill set today on the market?
There is that. You can find that the skills on the market. That's not the correct question. The correct question would be, what would be the price for that? The price of the human labor, let's say, dedicated to AGVs and AMRs is growing almost every day. It's amazing.
You mentioned that how important it is to design the application to be able to have a successful project. But the reality is that very few things are fixed. So the application that you design today, in a couple of months, could change.
That's correct.
How do we keep flexible in this environment?
From an application design point of view, you have to redesign in many cases. In some others, you don't, but you still need flexibility coming from the technology itself. So you have to be able to deploy an update on the layout or on the technology itself. And you need flexibility coming from the technology anyway.
If today we have, for example, an AMR application, which is picking a pallet on one point, leaving it on the other, 1 ton, and in 2 weeks, they change the pallet size and now it's 3 tons. That AMR maybe cannot any longer
then
withstand this.
You have to redesign the application from scratch. Absolutely. Not always, but in many cases. If you are going from 1 ton to 3 tons, most probably.
What do you think is the biggest blocker right now to bring new AMR solutions into companies from different brands, providers?
For me, again, I repeat, the most important stoppers are fear at the company and the lack of knowledge at the company. That's why they don't invest more on AGVs and AMRs.
But once you decide to bring in a new provider, a new brand of AMRs, for example, for a new solution, if they need 3 tons and the current provider doesn't have 3 tons, what are the biggest challenges that they are facing? Do we have a challenge of a standardization?
We do have a challenge in a standardization, but in a standardization of the load itself, not a standardization of the AGV. So the standardization comes from the load that you're moving, not from the AGV itself. So let's say that the AGVs are slaves of the load that they have to transport, not the other way around. I think that if you are changing, if there is a change in the type of load that you are moving and you have not taken care of that in advance, that may be a wrong design of the application. It can happen because when you are designing a mobile robotics application, you don't have to think only on the current or you don't have to think about the current conditions, but about the future conditions as well. So you have to keep that in mind when you are designing an application. And if there is an evolution in the load that you are transporting, most probably you have to redesign from scratch.
Thinking about the different AMR providers, many of them are using different communication protocols, different objects in their libraries. Is this a challenge? Is it a stopper in the adoption of combined solutions in the industry?
Yeah,
and what do you see the solution? Where do you see the future?
That's a stopper. The lack of communication between or among AGVs and AMRs from different companies, that's a stopper in many cases. Definitely. And for sure, it is clear that the standard would help there. And that is absolutely true. And the future will come in that way. So in the future, we'll see a standardization of communication protocols, for sure.
How will that help the industry?
So the idea of the end user is that he has to be able to choose the best AGV or AMR for his needs, no matter what company is providing that AGV or AMR. And that will be the future of this industry, clearly.
Do you think it will enable applications or integrations that are not possible today?
Sure.
Which ones do you think? Anything in mind?
No, for sure. Any application that you can find in automotive industry can be affected by that. Right now, in many automotive plants from many different brands and companies, they have more than one type of AGV or AGVs and AMRs coming from different brands, and it's very difficult to mix them. So to have mixed flows, and that is a stopper today. For sure, that's a stopper.
You have quite a lot of experience coming from ASTI in the automotive industry, I understand?
Mm-hmm.
When you have an implementation of a fleet of robots and an automotive plant, how do you troubleshoot issues to find out the root cause of the problem? If it's a problem of perception, if it's a problem of process. Just putting an example. We have an AMR and someone leaves a box somewhere and the robot, instead of going around it, it just stops. As an integrator, how can you troubleshoot that?
That is obstacle avoidance. I would never do obstacle avoidance in automotive industry, so it's not a good example. Troubleshooting problems in AGVs and AMRs working in automotive industry is in a first step linked to a monitorization. So first you need to know where is the problem. Because in the end, you're going to have, 1,000 AGVs and AMRs working around. So you need to know if there is a problem in one circuit or in a certain at a certain point. So first you have to detect that. For that you need a monitorization in most of the cases. And second, the way to solve it, usually you have 3 levels of maintenance. The first level of maintenance is the most simple, mostly related to cleaning and simple things. The second one is more technical, related to the hardware of the vehicle, and the third level is linked to software and software-related problems. So once that you have detected an error, you have to go for level 1, level 2, or level 3. And then, depending on what level this error is found, you have to decide what kind of what's the level of expertise that you need for that particular level. So, what person or what technician is going to answer that error, depending on the level.
Okay. This podcast is brought to you by Synaos, the all-in-one intralogistics platform, orchestrating trail flows with mobile robots, forklifts, and people to overcome cost pressures and skilled worker shortages. Visit synaos.com to learn more. What do you have to say about VDA 5050?
The most common question today in mobile robotics. VDA 5050, it's a standard, but it's not a holistic standard. So it's a standard between mobile robot and fleet manager. And it only takes that into account. And I think that the future will go, or we'll see that the future will go through more holistic approaches to standards or to communication protocol standards.
But you're thinking about plant automation standards like OPC UA, or?
No, I'm not thinking about that. But what I mean is that when you decide a communication protocol between the mobile robot and the fleet manager, you don't only have to take into account the communication protocol itself, but for example, the map that the AGVs or the different AMRs are using. And that's something that you have to take into account when you're designing.
Mm-hmm. What have you seen as the most common challenge when trying to scale automation?
From the end user perspective or from the provider perspective?
From the end user.
When so we're coming again to the application design thing. In most of the cases, the most important stopper that you can find to scale is that you have to change your processes to be able to automate them. And that is difficult in many cases. That is so difficult, particularly in automotive industry. I am always insisting that, for example, in the case of automotive industry, it's gonna be very difficult to reach a high level of automation if you're not working with kits.
With what?
With kits. With kits, that's the name, kitting.
Okay, I thought you wanted to manufacture in some other country with kits.
No, kits, manufacturing kits, that's the name.
Okay.
In German, Warenkorb.
Okay. Tell us more, please.
It's a concept coming from lean manufacturing from Toyota, in fact, and it has been developed for many years ago, and it has been applied in some manufacturers, in some OEMs, automotive OEMs, and not in some others. In my opinion, if you want to reach a high level of automation, of intralogistics automation in assembly plants, you need to go for kits. You cannot if you're working in a different way, it's going to be very difficult to deploy many AGVs. For example, the strategy led by first PSA and then Stellantis regarding intralogistics automation was completely linked to the use of a kit for the assembly of cars and doors and cockpits and many other different sub-assemblies of the car.
Where do you see, or what do you think are the industries that have the higher chance of not disruption, but wide implementation of mobile robots that are not yet there?
So the next industry is booming in the AGV AMR industry. Airports, clearly. That's for me the next one. It's starting right now already.
But that will require a very, very close integration between the tractors and all the other operations.
Sure, just like an automotive plant. It's the same thing.
Okay.
An airport is actually somehow similar to an automotive plant.
You also have control towers at
For sure.
Okay.
Actually, I don't know if I can say that, but if you go to a big automotive plant here in Spain, a particular one in Northeast, they have a control tower.
Wow.
It's called that way. They call the control tower, and they control the AGVs from there. Well, not only the AGVs, many other things.
What is the software that we will need to be able to implement all these new applications that are coming in the next years? What does it have to have?
Easy to install, easy to operate, and efficient. The more efficient, the better. And able to manage thousands of mobile robots at the same time.
What does it mean, a more efficient software?
And it's a little bit like Google Maps. So when I am saying efficient is if you compare the Google Maps that we are using today versus the Google Maps that we used 10 years ago, it has nothing to do. Today is much more efficient. It takes less time for you to go from point A to point B than 10 years ago. Because they are taking into account many more factors.
Maybe not anymore. Now they made Google put like the most energy efficient trip.
The best one is Waze. but that's more or less what I mean. So they are going to put more things into the equation, and most probably they will be using artificial intelligence as well. Well, they will be using artificial intelligence.
I was sitting down very recently with a company that's making surveillance robots. You probably know them.
I do.
About the use that they are making about artificial intelligence to, for example, take a picture and know if a window is open, if there is a yellow banana or the banana is rotten. Do you see applications? Are you seeing applications that are already implementing AI in this way, for example?
No, not yet. But it will come soon. It will come. The use of recognition, so regarding your example, the use of recognition right now in AGVs AGVs and AMRs for intralogistics is not that common, because the target is to reduce the cost, the operational cost, or to substitute the labor, the human labor. Therefore, that kind of solution is not interesting. But yeah, we'll see more and more AI coming to mobile robotics in the next years.
Where do you see the most interesting use cases of AI in intralogistics?
Installation. It's actually very similar to a Roomba at home. So you want the Roomba to install as soon as possible, or as fast as possible. And ideally, the Roomba has to install itself. So I don't want to do nothing at all. So I want the AGVs and AMRs in my automotive plant or in my logistics distribution center to install themselves. And that's what I want, and as fast as possible.
NVIDIA, for example, has announced very recently that their new GPUs are being designed by AI, because they can make traces and the processes of the processor way better than a human could ever do in many times.
Absolutely.
Is this going to happen also with the processes of AMRs?
Yes, that's part of the installation itself that I was mentioning before. So the way the software decides what AGV is going to do what, that's going to be decided by an AI. Clearly. And not only that, so regarding the mission allocation, that would be driven by AI, but the traffic will be driven by AI as well. So both at the same time. And you will have to take in, or the software will take into account both the mission allocation and the traffic in both directions. So they will cross information. And you will know in with certain time in advance what would be the best route. So imagine that you have to go from point A to point B. And you are going to perform this route in 10 minutes. So you need to see what will be the status of the whole area in 10 minutes. So the calculation will be done in advance.
Mm-hmm.
And it will be not just one calculation, it will be so many calculations, right? And this calculation, taking into account trends and so on, will be done before the mission is generated. Today, those calculations are done once the mission is generated. So I have the mission, and now I decide. I don't take the decision, or I don't make the calculations in advance. In the future, that calculation will be done in advance.
What do you think are the most common myths about automation, and what is the reality?
When you say myths, what do you mean?
Myths, things that people believe but are not true.
The most common one is that if I have a manual machine, I place an automated one and it will work. That's the most common myth, clearly.
And specifically about intralogistics and about robots?
That one. No, that one clearly. But many people. So this is the first one. Absolutely. There are others. Which you have mentioned actually before, obstacle avoidance. Many people think that obstacle avoidance will help them, and that's a myth. Obstacle avoidance is, in most of the cases, a problem. It's not a solution. And when you have been working for some time in this industry, you realize that it's true. So obstacle avoidance is an interesting myth as well.
So AGVs or AMRs?
What's an AGV and what's an AMR? And this is a long discussion. And what you are... so the technical definition of an AGV and the technical definition of an AMR, difficult to say. It's difficult to make those definitions. And maybe it's different for you than for me. Even we can discuss if obstacle avoidance is a feature of AMRs or is a general feature. So what's the difference between an AGV and an AMR? The localization? The obstacle avoidance, or they are more clever?
If it has localization, but it follows a predefined path, I would say it's an AGV.
What's a predefined path?
I would say it doesn't have...
magnetic tape on the floor?
No, because you can have a virtual tape. So
okay.
There's not a problem. But if it deviates from its intended path, for example, with obstacle avoidance, I would say it's autonomous. But yeah, it's a thin line.
Extremely thin line, and depends on whom you're asking. No, in most of the cases, obstacle avoidance is not a good idea, and that's a big myth.
Why?
Why is it a good idea? Let's go the other way around.
You can adapt to the current real scenario.
Why do you want to adapt? What happens if you adapt in an automotive plant?
Maybe not in a automotive plant, but in a more general scenario, someone leaves a pallet where it shouldn't be.
Maybe I arrive late to deliver the pallet as an AGV due to that fact. Or maybe I have to go around through and use a different aisle and I arrive late. Why is obstacle avoidance a good idea? In most of the cases, you then realize it's not a good idea. The only place where I can see obstacle avoidance as an interesting feature is in cleaning applications.
Okay.
And when you are working in crowded areas, for example, a station, or I don't know, the streets, there I can understand so. But in industry or logistics, forget about it. It's never a good idea. Think that in generally speaking, in intralogistics, you have to arrive to deliver something or to pick up something at a certain time. And if you arrive late, there's a problem. Obstacle avoidance is not a good idea in most of the cases. By the way, never ever in automotive industry, really.
Okay.
Imagine that you have to deliver a box to the assembly line at a certain point and you arrive 10 minutes late because you have to avoid an obstacle and go through the other aisle. It doesn't work.
That's interesting.
That's an important myth.
But my question was, it's better to arrive late than not arrive? So what happens if there is something in the middle?
But maybe you arrive late, maybe you don't arrive once.
And you fix it, and then all the others arrive on time.
Never happens again. Actually, that's the point.
If you do obstacle avoidance, you should be able to notify the fleet management software that there's an obstacle to be fixed.
But what happens? Nothing. Nothing, because the AGV delivers late. But you cannot deliver late. It's not an option to deliver late. In the end, so if you allow people to leave pallets around and do whatever they want,
it's going to be a mess.
Yeah, it's going to be a mess. And they will not do it just once. They will do it all the time. And they will not place just one pallet.
Yeah.
They will put a second pallet and a third pallet.
Where do you see the future?
What future? The mobile robotics future?
Mobile robotics and intralogistics. What good news do we have on the horizon?
The localization solutions are evolving. That's kind of good because they seem to be more flexible and more robust. That is true. But we are still missing a lot. What we were saying before, that when you want to automate, it's not as simple as substituting a manual machine with an automated one. So I would like to say that the good news is that people are starting to think in that way, but no, it's not. It's not true. Most of the customers, they still think that it's as easy as substituting the manual one with the automated one, and that you don't have to design an application for mobile robotics. The only good news that I can see is that we have new technologies for localization, to be honest. There's another good news. Yeah, the installation time is decreasing. That's true.
Thanks to what?
User-friendly software. 20 years ago, you needed an a technician coming from the NASA or I don't know, the CIA to be able to install an AGV. Today is much easier. That's true. It's not short enough yet, but the installation time is decreasing. Yeah.
Any final statement you want to make?
I'm not sure. Do you have any other question?
What if you want to learn more about Javier Miguelez, moving robots, or ARME?
I don't know. That's a good question. This was not planned. I don't know. No. I always insist in the fact that you have to design an application. If you don't design the application correctly, you are dead. The project is not going to work. And that's extremely important.
Amazing. Thank you very much, Javier.
My pleasure.
Thank you for joining us. Hope to see you back soon. Thank you very much.
Thanks for listening to Intralogistics Insiders. Stay tuned for more insights and subscribe on Apple Podcasts, Spotify, or your favorite platform.